All right. So next thing we're looking at are exponential functions. If I'm going to talk about an exponential function, you need to know what I'm referring to. So we know a function passes the vertical line test, right? X doesn't get repeated. It's something that's written f of x equals. When it's exponential, the variable is in the exponent. So the exponential function is something of the form f of x equals a to the x. A is just a positive number, and it's called the base, and then x is your variable, and that is located in the. So first, I just want to kind of refresh. We have dealt with a lot of simplifying exponential functions, but just a nice, easy problem to get us going on a Monday morning. If f of x is equal to 4 to the x, when I say f of negative 2, so we know in function notation, that means you are plugging the negative 2 in for the x. What does a negative exponent do? Just does the reciprocal. So 1 over 4 squared, 1/16. Okay, if I say f of 5, that just means 4 to the 5th power.
1024.
Thank you. Okay, if I said 4 to the 3 halves power, what do we do with fractions? The square root of 4 cubed. What's the square root of 4?
2.
And then 2 to the 3rd.
16. 8.
We could have decimal exponents. Do we have any way of working out 4 to the 2.15 power? No, so sometimes we are just going to have to rely on our calculator.
Every single time.
And so that gives me 19.6983.
Why couldn't you even just put the 4 to the 3rd power in?
Why couldn't you have done the fraction or the calculator in this?
No.
Oh, 4 to the 3rd is 64, and square root of 64, that also works. Either way.
But yes, you could just put 4 to the 3 halves.
You could, except if it comes out to still have a radical in it, your calculator will give you the decimal, and I would hate that. Kind of wrong.
Good thing we did that.
Okay. So let's talk about graphing these exponentials. So the first one we are going to graph is 2 to the x power.
I'm not writing all that.
So if I want to graph 2 to the x, all you really need to write is f of x equals 2 to the x. If we don't know what something looks like, how do we graph it? And if I want exact points, what do we have to do?
T-table, T-chart, whatever. T-table.
No.
Isn't that T-chart? Yeah,
Yes.
it's
Alright, if I plug in a 0, what's 2 to the 0 power?
1.
If I plug in 1, what's 2 to the 1st? If I plug in a 2, 2 squared, bless you. What happens if I plug in a 3? 8. If I plug in a 4. Okay, so it's just getting larger. Let's put in some negative numbers and see. If I put in a negative 1, a negative exponent just flips it, so it gives us 2 to the negative 1, so 1/2. So negative 1 1/2.
-0.
Let's try negative 2. So that would flip it, so it'd be 1 over 2 squared. Okay, will you ever do 2 to some power and get 0 as an answer? No. Will you do 2 to a power and get a negative for an answer? No. So our graph looks like this.
Yes.
The x-axis here is our horizontal asymptote. Because there is nothing we can plug in to make it equal 0. It's going to get closer to 0, but it's not ever going to actually equal 0. What is the domain of this? And how do we write that? Range. What do we get?
0 or comma 0 to
Is this increasing or decreasing? It's always increasing. Okay. So were all of these points necessary? Maybe.
Yes.
Bare minimum, when you are graphing these, you need to put in at least 3 points. We usually just do 0, 1, and negative 1. And that should be enough to kind of get an idea of what this graph looks like, because we know we'll have a horizontal asymptote at the axis, and we know it's a curve that would look something like this. Okay, so you can do more points, but at a minimum, 0, 1, and negative 1. If I did... That wasn't it. It was 1/2 to the x. What's the second one? Okay. So if I follow those same rules, I told you bare minimum 0, 1, negative 1. What is 1/2 to the 0 power? What's 1/2 to the first? What's 1/2 to the negative 1?
2.
Let's see if that's it. Okay, we can plug in more numbers if we wanted to. If I put in a 2, 1/2 squared is 1/4. If I put in a negative 2, that would just flip it, and we would get 4. So can we tell what this looks like? What happened? That fraction for my base just made this graph decreasing. So when my base is something bigger than 1, like a 2, 3, 4, then it's an increasing function. When it's smaller than 1, so 1/2, 1/3, 2/3, then it's a decreasing function. Did my asymptote change? No, I still have a horizontal asymptote at the axis. What is my domain?
Negative 35.
What is my range? Still 0 to infinity. So nothing changed except since my base was smaller than 1, this function was actually decreasing instead of increasing. Yes. Range could change with transformations, but domain will always be negative infinity to positive infinity on these. All right. Is that okay? Let's, I'm not gonna do that one. Let's do some transformations with these. So we're going to graph these things. On your graphs, I will be looking for a minimum of 3 points. I will expect parent function and transformations just like any others. Just to ruin your day. That's what I'm here for. Very good at it. So your parent function is just a regular exponential. So a positive number to a power. So if I'm looking at this, my parent would be just 3 to the x. But we can graph that, right? How many points did I tell you you have to have for that? 3. So if we do 0, 1, and negative 1. What is anything to the 0 power? Okay. What is 3 to the first power?
And 1/3.
And the negative flips it and 1/3. So this is my parent function. You could do more points if you wanted, but it's not required. So now, if I'm looking at my transformation, what would a negative in front do?
Flip it over the x-axis. Flip it in reverse.
So I have my 3 points, and if I flip these over the x-axis, they just come down. What is the domain?
Negative any positive.
And what's the range?
0 to negative.
Negative.
Oh, that's crazy. Same thing, different.
Just go small to large. Okay. Let's do.
Oh, let me graph and do that. Height.
Word up, right?
What if I said 3x minus 4?
It's a secret. It's literally a secret. It's not out yet.
Okay. What is my parent function? Right. Your parent function is just a positive number to a power. So that's what I'm going to graph first. 3 to the x. You can write out your t-chart if you need to. You are not required, but I have to be able to clearly see your points on your graph if you don't write it out. When we do that, we're just doing 0, 1, and negative 1 for the parent function. So 2 to the 0, 2 to the first, and 2 to the negative 1. So we have 0, 1, 1, 2.
Use Bailey's points to the right. 4. Yeah. Don't we bring it to the right 4?
I'm going to do that in a second. I'm going to do my transformation. So I'm just doing my parent function to start.
What do we have to do, paragraph?
Yes. Like using transformations, dude.
Alright, so a minus 4 on the end. This is not attached to the x, it's on the end. So that will take my graph down 4.
Oh, right. Like I said.
If I'm going to move these down 4, what else do I need to move?
Horizontal asymptote.
Right, I had a horizontal asymptote at 0. When you move up or down, that asymptote gets shifted as well.
You got it.
So what's our domain? Yep, every time. But because I moved my graph down 4, it did change my range.
Negative infinity is
Negative 4 to 3.
Thinking about the y-axis, I didn't have anything until I got to negative 4, and then I had everything above that. So negative 4 to positive infinity.
Alright, we good.
I'm going to do 2 more.
One more we gotta do.
Struggle, do you have allergies yet in your house?
Thankfully no. I mean, we have sickness, but the allergies haven't hit yet.
Allergies and sickness. So.
Like, go back. So that's it.
my allergies usually give it a couple more weeks when the trees start blooming. That's when my allergies start.
They're already gone.
Alright. What's my parent function?
1/3.
Alright. So that's what we're starting with my 0, 1, and negative 1. 1/3 to the 0, 1/3 to the first,
1/3.
and 1/3 to the negative 1. 0, 1, 1, 1/3, negative 1.
Why didn't they use that back?
Huh?
Okay. What will this plus 2 do to my
Let's
graph?
do what?
Does that move my asymptote? No, it's only going to move if we go up or down.
Thanks for clapping.
Domain? Range?
That's not that good.
Alright, I want you guys to try one. Let's say I gave you,
Why do we always have to try one? It's the last one, right?
if we do okay with it, yeah.
Oh, yep.
Swag. Alright, no question, right?
Swag.
Okay, so how do I?
Let's see.
It's gonna make it almost
I'm
impossible.
supposed to know. Not.
Oh my gosh. That bad.
Alright, what's my parent function?
4 to the x.
Alright,
Oh.
so 4 to the x, so you do your 0, 1, negative 1. 4 to the 0 is 1. 4 to the first is 4. And 4 to the negative 1 is 1, 4. So, your original, you have to have 0, 1, 1, 4, and negative 1, 1, 4. Then, we have to figure out our transformations. So, the minus 1, we'll take it, and the plus 2. Since I'm moving up or down, my asymptote moves, so it will go to positive 2. So then we go
They
right.
did spell down. Spell down weird. That's crazy.
Huh?
Nothing.
You spelled down wrong.
Yeah.
Because of you and you.
I don't know what that UP is, but
Crazy. So that's my final. What's the domain of this?
Another value array.
And the range?
That's so
messed up. I did. It's something.
Alright, I have a canvas.